Okay, up now we have Graham Ollis with FFI Performance.
Hello there, everybody can hear me? We're all good? Okay, my name is Graham Ollis, and I have an admission to make. My favorite animal is the platypus. For those of you who don't know, platypus is an adorable aquatic mammal that has a duck bill and it lays eggs. It's also, being an Australian animal, mildly poisonous. So it's an unusual creature. When it was discovered by Europeans back in the day, they did what they did in those times, which is they sent a sample back to England. It was a long journey, so it wasn't a living sample, and when it arrived, they thought for sure it was a hoax. They felt that somebody down under had stitched the beak on and were playing a practical joke on them. But this is a real creature. I've seen one in the Sydney Aquarium. I've even seen one in real life, which is, in the wild, which is it's special because they're quite shy. And I saw this in a river near the Genoan Caves one day, which turns out to be a wonderful environment for them because they're well adapted to thrive. And today I'm going to talk to you about technologies, combining them together that you might think don't really belong to each other, but for your application, you can use them to thrive in a computer environment. I'm going to talk to you today about the C library, libFFI, and its Perl bindings, FFI raw. So what is an FFI? An FFI is basically, it's a method of combining different programming languages into the same application. And for those of you who've been paying attention, you probably know that Perl already has its own FFI called XS. It's basically you have some XS code that gets compiled into C code, that gets compiled into machine code, which then gets called by the dynamotor. Now, if that seemed like a lot of steps, then you're right, it's kind of indirect, there's a lot of indirection. So with libFFI and the FFI raw interface for it, you can call directly into any dynamic library that is, so for any language basically that produces a shared dynamic library. And it also works, the same technique is available in a lot of other languages like Python, Ruby, Java, Scala, whatever. And just for a quick example, this is, say you have a very simple C function that simply returns the value that you pass into it. In order to call that using FFI raw, you create an instance of FFI raw. You give it the library name, the name of the function, the arguments, and the return type, and then you can call it as a method on that instance. So what are some of the advantages of FFI over XS? For one thing, XS is inexorably tied to Perl 5. It's never going to be available in any other language, not even Perl 6, because nobody in their right mind would implement it that way today. FFI, on the other hand, is tied to libFFI, kind of, but it's used in a lot of different languages. You know, there's a similar, I'm not sure actually if it uses libFFI, but Perl 6 has a similar technology. Python uses it, Ruby uses it. There are also other libraries that essentially do the same thing, like ffcall. Java has something called JNA. So you can use the same technique in Java, Scala, or whatever. XS is also tied to C and C++ pretty strongly, and also the C preprocessor, which is personally something that I don't really like. I mean, you look at a piece of XS code and you're not really sure what the performance implications are unless you're really, baked into the Perl core. You know the guts really well. FFI, on the other hand, it will work directly with any language that produces machine code. So C, C++, Rust, Fortran, if you're Brave, assembly, whatever, anything that produces machine code. I also find the documentation for XS to be confusing, dense, incomplete. On the other hand, really understand that well. You can be ingenious in XS, but it doesn't really transfer to anything else. So on the other hand, FFI, it really transfers your skill set to other environments in a useful kind of way. The big disadvantage of FFI, I think at the moment at least, is that FFI raw itself is implemented in XS. So there will always be a certain amount of overhead in using it. Depending on how good you are at XS, you might be able to write something faster in XS than your equivalent FFI code is going to be. So a real life example, what this does is it uses, so I wrote a module called archive libarchive FFI, which is an FFI interface using FFI raw to libarchive, which is basically it's the tar implementation that comes with regret BSD, and it's provided as a library, and you can use it on a lot of different platforms. So this is actually a pretty close translation from an example code that they provide in C into Perl using my library. And what's kind of interesting about this is that I also wrote an XS version that provides the exact same interface. So it was kind of an exercise to compare and contrast the two techniques. So we can run some benchmarks and see how fast or slow it is. And this is, so caveat on benchmarks, obviously, whatever platform and you're running on is going to be different, but it gives you an idea. In this example run, which was more or less the same as the others, it's taking not quite twice as long to do the same work. So, you know, are there some things that we can do to make this look a little bit faster? Sure. You know, one thing that we can do is when we call an FFI function, we use this method dispatch. So we say test one arrow call to call this method, to call this function, but you can kind of cheat and just do a function call. This actually is cheaper because you don't have to, Perl doesn't have to figure out what the actual method to call. I think Perl does some caching on this, and it is actually pretty fast, but you do get some you know, shade tree cycles by doing this. Another thing you can do is you can actually start working on the FFI layer itself. So, so this is, I showed you the FFI raw example. I started working on sort of an experimental FFI interface as a potential replacement, and I called it, of course, FFI Platypus, because I'm obsessed with Platypus. And one of the differences in the interface is that I create a real live Perl subroutine in your namespace. And the trick to doing this took me a while to figure out how to do this, but the trick for doing this was using something called CVX sub any, which given, so a CV is a code value. It's basically the thing that a code reference points to. And you can attach a pointer to that. And so the actual C function that implements the calls is the same for every single function. And it just, but the code value is different. So you can attach the argument and return types to the CV using this anchor. So here I am. When I create the subroutine, I use CVX sub any to sort of attach this extra information. And then when I call the function itself, I can grab this again and then use that in order to make my call. So this actually makes certain calls much faster. So another thing that I did was FFI raw does a malloc for every single argument that you pass into it, which is kind of silly because you're not really saving any memory when you consider the overhead. And it's also kind of slow because lots of mallocs are going to slow down your performance. So I used I allocate, first of all, I allocate my memory in sort of two big blocks, which is going to be faster. And I also experimented with using Aloka, which is a little controversial. It should be used only sparingly, I think, and some people say you should never use it. I think in this case, I'm basically storing argument pointers and integers and things like that, and I think that's fairly close to what you do when you're making function calls anyway. So I think this might be a legitimate place where you could use it. You also have to test to see if it's available, because a lot of platforms don't support it. So I made these optimizations to Platypus. I also tried some other sort of interfaces just to compare and contrast. I tried two traditional FFI interfaces, XS and inline C. FFI raw is the one that's available on CPAN right now today. You can write modules with it. FFI suite, it's under development. It's on GitHub. So when I wrote archive lib archive FFI, I actually used that interface, but it wasn't available soon enough. So I created sort of a light version of that. I tested that as well. And of course, this sort of experimental interface that I've been working on called Platypus FFI. So the first benchmark I tried was this same really simple function that I showed you before, and a cute platypus. And this is sort of typical of the sort of numbers that I was seeing. Platypus is actually pretty close to the inline and XS performance. I mean, this is a really easy sort of call to make. It's just integers, single integer arguments. But if you compare it to raw, for example, it's much slower, and suite is really slow. I think we just need to attach a profile and see what's going on there. Is that any questions so far? No? Okay, so another thing, so make it a little bit more complicated, pass in a string, return a string. This is more complicated because usually you have to allocate memory in order to do this kind of thing. You have to, depending on the way the language stores its strings, you may have to translate it into a C version. And as you can see, so caveat, Platypus, I never bothered to implement strings, which is probably an important feature. So I can't compare that one. But I think that it would live somewhere between raw and inline if I managed it. Okay, this version is lots of arguments. So you're doing in raw, you're doing lots of mallocs, and you can see that Platypus, it becomes a bit slower. It's about twice as slow, maybe a little bit more, but it's still much, much faster than FFI raw. Okay, so the other thing I think that you should think about when you're reaching for your XS toolkit is how much your time is worth. And this is the man page for Perl XS, and I have actually read through all this. You also need to really understand Perl API in order to be really good at XS. So before you think about how much you're optimizing by using XS, think about how much time you're wasting, human time. So some resources to take a look at. I talked a lot about FFI raw, but this isn't a platypus, but it is an Australian animal, Australia rules. Okay. I'm not the author of FFI raw. Sometimes I don't make that clear, but the guy who does maintain it is really good about accepting patches. I've had a bunch accepted. FFI performance, it's not a real CPAN module, it's just the GitHub stuff that has the code that I wrote to run these tests if you want to check and see if I lied. There's a number of FFI tools on CPAN. I wrote FFI util to manipulate pointers. I wrote FFI checklib recently. This is sort of like extension utils checklib except for FFI, because there wasn't anything really good for like this on CPAN. There was lots of things that were good at finding like static libraries or when you use a compiler. But for FFI, you don't actually need development libraries and stuff like that. So this sort of is smarter for FFI. I wrote FFI tiny ECC recently. It's a sort of, it uses a small C compiler, so you can compile code in your Perl process and run it from FFI. There are also starting to be a few extensions on CPAN now, other than the ones that I've written actually, that use FFI. There's archive, libarchive, FFI is the one I mentioned. There's zcrypt. I don't know much about these, but these are some good examples if you're interested in playing around with it, how it works. I'm me. I'm pretty friendly. If you're interested in this stuff, then maybe we can collaborate or whatever. Or you just have a bug you want to fix, let me know. That's kind of it. Do we have any questions now? Yes?
Yeah, why didn't you add the character string support to the Platypus?
I just haven't had time to do it. Other things that, right now I'm actually thinking that the correct course of action might be to take some of these ideas that I've come up with and apply them to FFI raw, because I do think that improving the speed there might be more appropriate than reinventing the wheel. It was kind of useful to be able to just like, try something totally different and see where we could make things better, but FFI raw is more complete at the moment. So. Anything else? Nobody? Yes?
So yeah, I haven't really done any excess either or anything. So as far as if I do want to, have something in Perl performance-wise, what would you recommend? Why? In mind, or I guess not excess. I'm not trying to maintain something or.
Sorry.
Well, yeah, but starting from scratch. What's the?
I think it really depends on how crazy you want to get into the innards of Perl. I think it's less about the performance actually, because a lot of things, like if you really want something to be high performance, write it in C. You don't use Perl or whatever. But if you and then there's an in between where you want to write a little part of it to be fast in C or whatever.
Right.
So I guess I should unplug them for the questions. It just depends, I guess. I would play around with. I think that FFI is kind of interesting because it's useful in a non-Perl context. I find that XS is. I'm kind of like weird things. I think XS is kind of interesting, but you're sort of tying yourself to Perl, and also like driving yourself crazy with the documentation. I don't know how to advise you, I guess.
You tried like deploying the FFI libarchive module. Did you also try using it through the FFI web?
I have actually. I played around with using it from Scala, and it was that was actually, that's kind of something that I wanted to touch on. It's just that if you look at like an implementation in Ruby, I've done this a couple times. I look at something that uses FFI Ruby, and it's really easy to then port that into to Perl or whatever. And so I had that same kind of experience when I was playing around with the Scala version. Well, it wasn't a full version, but it was just like coming really fast. And another thing that I think would be interesting is if you could save this sort of metadata in kind of a language neutral format, like JSON